the Apogee Up Close webcast. We do this webcast twice a month, and the topics are based on popular demand. You can sign up multiple times, and you can ask questions live. Hi, I'm Keith Danikind. I'm a customer solution architect with Apogee, which is part of Google Cloud Platform. Today we're going to talk about a brief overview of Apogee Edge, and we're going to talk about an interesting topic that customers ask me about all the time, and that's how do you build an API that combines the result from two different backend services? So let's say you wanted to have an application, and it needs to get information from multiple backend systems, but you want to present that as one API. So we'll take a look at that, and we'll follow up after that with a question and answer session. So before we do that, let's take a look at Apogee Edge. So this describes the philosophy of our platform. We've seen a repeating pattern of success with our customers, and it's driven by how they think about the problem. It requires a shift in thinking. Traditionally, we think about this from an exposure point of view. We can just expose the service and be finished. Think about the right-hand side of this diagram. Thinking about it from the end user's point of view leads to much better results. Our successful customers start from that end user, thinking about what that user's experience will be like, and working backwards from there. Providing the application developer with great APIs reduces the complexity of creating new applications. The application developer is free to focus on user experience and iterate on a few different designs. The API team makes this possible by providing easy-to-use APIs with consistent interfaces and security. And the API team builds an API facade on the existing services, abstracting away the complexities. Apogee Edge makes it easy for your API team to build great APIs. Apogee Edge also makes it easy for developers to consume those APIs. And it also lets you measure every aspect of your API program. So how's that work? There are a set of services in Apogee Edge. Apogee Edge is a single platform with three conceptual parts to it. API Services allows us to expose and manage a service as an API. Developer Services provides a portal where application developers or API consumers can learn about your APIs and request access to them. And Analytics lets you measure every aspect of your API program. So let's look at those in a little bit more detail. So API Services is where we build our APIs. On the left-hand side there, we've got applications, maybe a mobile application, a web application, or a partner system. These applications make API calls. They send HTTP requests. Apogee Edge lets you pass the request straight through the backend system, or you can change anything in the headers, the URI, or the body. You can even do intelligent rate routing based on the caller. And you can also manage the flow of traffic by imposing rate limiting or quotas. You can apply caching. When the backend system returns a response, you can send that response straight to the application or change it as needed. For example, you might send a reduced payload to a mobile client or transform XML data to JSON format. You've got complete control over that request and response flow, and you can manage all the traffic flowing between here. After you build some great APIs, you want to make it easy for developers to discover them and start using them. The developer portal gives you a place to put your documentation and tools to let developers register for access. People can try out your APIs from the documentation. They can fill in data fields and see what request and response flows will look like. The developer portal reduces the friction when getting started with your APIs. So after you've built a few APIs, your application developers have discovered them from looking at your portal, and they started to send you traffic, it'd be great if you could measure your API program. The analytics system in Apogee Edge allows you to measure every aspect of your API traffic. You can measure operational details like response time and frequency of different types of errors. You can find things that are interesting to your business, like where people are located, when they call your APIs, or which applications are sending the most traffic. Maybe it's interesting to see what type of client they're using. So let's talk about a common request that I've heard a few customers ask about. How do you build a composite service? So how do we take two or three services and make them look like one service? So let's look at a sample application, and then I'll go into some detail about what's behind this application. So I travel frequently for work, and a lot of times when I travel, I want to know what's the weather going to be like when I get there. Do I need to bring a big coat with me? Do I need an umbrella? And where can I get something to eat? So I've written an application here I call Nearby. And what I can do is I can type in an address, a street address in here, and I can pull down the local weather and a list of restaurants. So let's say I'm going to visit the Google office in Boulder. I might want to look up what's there. This will call my API, and it's going to come back with two different things. Some local weather information and a list of nearby restaurants. That's exactly what I want. And there's one API to support this application, but I'm calling three different services on the back end in order to make this happen. So let's take a look at those services and let's see what's behind this. So here's a high-level view of what's happening in the application. I'm typing in an address over there on the left-hand side, a street address, and I'm sending that into Apogee Edge. And then I'm going to call two different services on the back end. One does weather and one does places. Those two services take a latitude and longitude, but I don't happen to know the latitude and longitude of all the places I visit. So I'm going to geocode that with Google Maps. So I'm going to send a street address into Google Maps. It's going to return a latitude and longitude. I'm going to make a call out to my weather service, and that's going to get me the weather for that latitude and longitude. And then I'm going to make a call out to Google Maps, and I'm going to request restaurants near a location, and it's going to return me a list of restaurants from that. I'm going to take those two results, combine them together, and return that to the calling application. So let's look at these three services, and then I'll show the API to talk about what's inside there. So let's look at the services that are behind this application and behind this API. So first one is a service called Dark Sky, weather service out on the internet. You can pay to use that. You send in a API key, which I've got stored in a variable here, and you send in a latitude and a longitude, and it returns a ridiculous amount of weather information. So lots and lots of weather information down to the minute. So more information than I need for my application. What I'm really interested in is just collecting this little section here called currently and just grabbing that. So things like what the current conditions are, what the temperature is, maybe the wind and things like that. So just the basic summary of wind, and I want to ignore everything else in there. The other thing I want to find, I want to get a list of nearby restaurants. So for this one, I'm going to pass in a latitude and a longitude, a radius in meters, the type restaurants, my API key, and then I'm going to get back a large JSON body over here that's going to show me a list of restaurants. And they'll be listed by latitude and longitude also. And we'll get some information in here. The same sort of thing if you search for restaurants on Google Maps. This is the data that's returned. So we'll see information about where the location is, what its hours are, when it's open, and things like that. So all of this is interesting too. I don't want everything out of there. I really just want some of these fields. So how can I take all this and combine it together? Well, before I was able to call this, I have to find this latitude and longitude because I don't know that off the top of my head. So there's one more API call in here. There's a geocoding API that's part of Google Maps. So here I'm going to call maps.googleapis, and I'm going to request back JSON data. And I'm going to pass in a street address or location and an API key. And what I get back from this is a lot of information about the particular location. And deep within here, somewhere within here, geometry, location. I want these two fields, just these two numbers. That's all I'm interested in. The rest of this is interesting, but I don't need it for this application. I just need this so I can send it to those other two services. So let's look at the API I built to take all this information, put it together, and make it into one service. So the final result of that is this service right here. And this is my API called Nearby. And it returns a latitude and longitude and the address that was matched to whatever I typed in there. A short section on the weather, and then a list of restaurants, and just the name, the price level, the rating in the vicinity, and the location. And that's all I really need. So let's look at the APIs that are behind this and what makes this run. So here's our API. What you can see in here is this is the target endpoint on the back end. Now you'll notice on here, this is the URL for the weather service. And it takes an API key. I'm going to look that up and insert it dynamically before that's called. So I'm going to insert that into the request before it goes to the back. Same thing with the latitude and longitude. These are in curly braces, and that's how we specify a variable reference inside of Apogee Edge. We'll call this URL, and that will return results. Okay, so let's look at what's inside the API proxy itself. So when a request comes in, we're going to go through a few different steps up here on the request side. I'm going to do a few more things on the response side. So let's go into detail on exactly what's happening in here. So first thing is a verify API key policy. I want to make sure that whoever's calling me is a registered application, and I want to be able to identify which application that is and who the developer is. So my verify API key policy will check an API key that's sent in from here. And it also has the side effect of populating a whole bunch of variables in the flow that give me information about which API product they're using, which application, who the developer is, things like that. I can use that information for dynamic routing. I could use it to control what comes back in the payload. There's a lot of different things I can do with that. Second policy in here is a spike arrest. I've set this to, I've currently got it limited to 30 per second. just to keep somebody from calling this too quickly and overwhelming my system. I'm going to get some API keys in here. So remember, my backend system, the weather system, that dark sky API, that requires its own API key. And also the call out to Google Maps to get the geocoding address, that also requires an API key. I've stored those in a key value map, and I'm going to go look them up and pull them down and then insert them into the request. From here, we've got a call out, and we're going to do a call out to maps.googleapis.com. And this is the geocoding part of it. So I'm going to send in the street address that was typed in the application, and I'm going to get back a latitude and longitude. So what we do in here is we're going to build a request for this particular call out. We're going to set the verb to get, set a query parameter for address and for the API key, and then store the response down here in Google Response, and then we'll call that URL. We get a response back from that in this geocode response. And in here, we're going to parse out some information. So I want 3 pieces of information. I want to know what the matched address is. Usually it's what I typed in, but it might not be. It might be something that's nearby there. So I want to get what the actual matched address was, and then I need that latitude and longitude, and that's what I need to send to the back end. So that was an HTTP call out to another service, and that happens before we call it the backend service where we were originally sending this. So we use a service call out for that, and then we parse the results here. The flow continues here, and then that goes to the dark sky API on the back end. That's going to return with some weather information. We'll get that great big weather information that I showed at the beginning there, and we're going to grab just the important stuff out of that. So we're going to grab the current weather conditions. So down here on the response side, response comes back, starts to flow this way. We've got an extract variables in here. That's going to use a JSON path to grab the currently section in here. Let's look at that and let's see what that's grabbing. So if we look up here, currently, we just want to grab, we come down from the root, currently we want to grab this particular section right here. That's what we're doing there. Next up, we're going to get the Places API key. And we need to make another call out in here, and we want to call Google Places, and we want to find restaurants that are also in this location. So similar pattern to what we saw up on the request side, we're going to build another request. So I'm going to take that latitude and longitude that I looked up. I'm going to put in 10,000 meters. I'm going to look for restaurants, and I'm going to send in my API key for Google Maps. There's the actual call out. I'm going to give it 30 seconds to respond. It'll return quicker than that, but that's a timeout. There's the URL, and then the response is going to come back to restaurant responses. From that, let's look at what we get from that. So that's down here. We get back all of this information. For each given restaurant, let's look up a particular one here. We get a lot of information. So we get photos, we get reviews, places, references, things like that. That's a little bit more information than I need for my application. So I want to filter that down a bit. First thing I'm going to do is just grab the results section in there. There's more information in there for paging if I wanted to go beyond 20 results and things like that. Other stuff I don't need. I just want the results. And then the next thing in here is I want to filter that down even further. So within that set, I want to remove a lot of different information. And then I want to compose the actual result I'm going to return as my API, which is a combination of the weather information and this restaurant information. So first, let's look at this JavaScript policy in here. So this is a Java callout if you haven't seen one of these before. So the idea here is within Apogee Edge, you can do Java, you can do Python, and you can do JavaScript callouts. I'm working with JSON data, and I like to program in JavaScript for that. So what this is doing is this is referencing a JavaScript file, reduceplaces.js, and that's right down here. So within here, I've got a little bit of Java code, and I'm going to get rid of a bunch of information that I just don't need. So I get back an array of restaurants. And within each of there, there's some stuff I don't need, and that's what I'm getting rid of here. So I'm going to get rid of the icon, the ID, the hours, the photos, the places ID, references, scopes, and types. The location, the latitude and longitude, is actually buried within a geometry section, and I don't want it down there. So I'm going to move it up a level. I'm going to take the geometry section out and just assign it to location there. And then I'm going to delete that. And then I'll set a new variable, context set variable, local restaurants, and then I'm going to take that JSON body and turn it into a string that can be used in here. So this will set a new variable called local restaurants. It'll have the value of the newly formatted response from the restaurants listing. Now the next policy in here, if we go back to here, what we'll notice is I've got another one called compose results. So compose results, let's go look at that. What I'm doing in here is taking those bits of information and merging them all together into a new response that never existed before. So I'm going to take all the information that I've been collecting from these different services, and I'm going to put that into this response. So let's look at this quickly over here to see what the response looks like. So there's three pieces of information in here. There's the location, which is going to show the street address that was matched for the one that we typed in, and the latitude and longitude. The weather section shows the current weather, and that's just the weather that we kept from the call to the Dark Sky API. And then the restaurants. And for the restaurants, we've deleted all the extra stuff we don't need, and we've just kept a few fields in here. So that's the three sections that come back: location, weather, and restaurants. So what's going on in here is we're going to go and get that variable from the proxy flow. We're going to say context get variable local restaurants and current weather. We're going to do a JSON parse, and that's going to turn that text into a JavaScript object, or a JavaScript array in this case. We're going to create a new result, and it's going to have three parts to it: the location, the address, the lat long, and then the weather and restaurants. So location, weather, and restaurants. And then we'll take this new result and we'll turn that back into a string, and we'll return that as our return. And that's the response that comes back from this API. So that's how we take those three pieces of information: the lat long we called out for, the weather, and the list of restaurants, and that's how we turn them all into one response that comes back from our API. And that looks like this. So what's nice about this is all that complexity of how we call things, where we get latitudes and longitudes and things like that, that's all hidden away. All we need to do is call this with a street address and the API key that's been given to us as an application developer, and we get back a purpose-built set of data. So this is exactly what we want for our application. The burden of dealing with all those systems, that's been solved by the API team. So at this point, we've got a pretty good API. It does everything we need. We can go and type in a street address. It'll return a latitude and longitude, pass that along to the two different backends, get us the current weather, get us a list of restaurants, and return that in a format that's custom built just for my application. So that's pretty good. But how can we make that better? So it'd be better if we could do all these things asynchronously. So we had two different callouts in there, three different callouts in there, and we're doing them sequentially. So first we're looking up the latitude and longitude, waiting for that result to come back. Then we're calling the weather service, waiting for that result to come back. And then we're calling up the restaurant service, and we're waiting for that to come back. And then we return that. So the response time for this is basically the sum of those calls, plus a small amount of overhead. It'd be nice if we could run some of those in parallel. So we need the latitude and longitude. So we can't really get by with calling all three of them in parallel. But we could call the latitude and longitude lookup first, and then do a parallel call out to the restaurant service and the weather service, and let both of those execute at the same time, and then get the results and combine it all together. So how will we do that? Well, let's take a look at that. So let's look at version 2 of the API with the asynchronous callouts. So mostly the same here. What's different is there's a JavaScript policy at the end here called find places, and we're doing something interesting in here. This is using the asynchronous callout feature within JavaScript. So what it's going to do is call the URL, but then not wait for the response. It's going to move on in execution. So it doesn't really take any time to execute because we're not waiting on the response. So what we're doing in here is building up a request. We need the latitude and longitude, and then the places API key. And this is our call out to Google Maps API. So rather than just doing that with a standard call out, we're going to do it here within JavaScript. And then we give it a name. So context.session callout response. And we're going to use that in order to check back on this response later on in another Java policy or JavaScript policy. So that's going to launch it, and then it continues on. It's going to call the weather API, get the weather results back. And then down here in reduce places and compose results, we're going to check on that. So within here, this is where we see that revisit. So right down here, we've got context session, call out response. This is checking, and this is going to block and wait at that time. So right here, we're going to wait for that if it hasn't already completed. So it would have been running in the background, and this is where we're checking on it. Then we're going to get the response back from that. We're going to grab just the content section out of that. That was the same thing I did before within the extract variables policy with the JSON path. But in here, we'll just do it in JavaScript. And the rest of the code's the same. So we're going to go through the restaurants, remove what we don't need in there, and then put this together. So that's really the difference in here, is that we're going to see this processing done here. And then in compose results, exactly the same. So interesting approach there. It's going to launch it here and then wait for it down here. And in the meantime, it'll make the call out. So the call out to the restaurant API will run in parallel with this one. Or I'm sorry, the restaurant API and the weather API calls run in parallel. And that should hopefully speed this up a bit. All right, so let's take some questions. Go ahead and type your questions in, and I will answer whatever comes up in there. Let's see what we've got in here. Another question here about, could you do all this in the request, or do you need to do it in the response and the request split up like I did? You could do it all on the request side. As long as you've got that request to the back end in the right format, you could do that. Or you do 3 callouts from the request side and then return the answer directly in there. So there's also the ability to have a no target API proxy within Apogee, so it doesn't actually call the backend. You could build the response up in there, and that's another option. So question here, what's the advantage of coding in Apogee versus coding the service aggregation in your favorite programming language and then simply exposing it via Apogee? Absolutely, that is an option. So there's what you can do in Apogee, and then there's what you can do in the backend. Your choice in terms of where you do that and what's appropriate for your architecture. I tend to recommend to folks that things like lightweight composites and reformatting of messages, that's appropriate to do in Apogee. You've got full access to programming languages. You could load up thousands of lines of business logic in there. I don't recommend doing that. So you could push that to the back end. For some folks, the back ends are not changeable. And so they're looking for this type of solution and being able to do it within Apogee because it's easier in terms of what their environment looks like. But you could do it in any place that you like. Can we publish a message to the JMS queue and wait for the JMS reply and then read back the response to the caller? So you could certainly push to a JMS queue. Java is an excellent option for that. So put something on the JMS queue in there and then look for the reply. Yes. What would happen if I removed the sleep of 10 seconds in my last example? So what that is, that's not necessarily a sleep. It's basically, that's the timeout. So if the service doesn't respond within 10 seconds, then we would generate an error, or we would have some logic in there to continue. But basically, that's a hook that you're going to get a signal after 10 seconds. It'll stop waiting, and then you're either going to have the answer or you're not. So it'll probably come back before that. And then if it doesn't, you would have some error handling in there to return something useful to the user. What's the reasonable limit on the number of calls that should be done in parallel? I don't know if there's a limit. Probably a few. I wouldn't go over 10 or 20. I mean, it really depends on you. Test it out and see how it performs. I tend to look at those in terms of usability from the consumer's point of view. So what would it look like if you're calling that API? If there's a high probability it's going to return an error or something like that, you might use that to determine that. Can we find this on Git? Can we find this as part of a lab? We don't have a lab for this, but I will. I'll try to publish this out on Git so that you can use this code and take a look at it. How do you send a custom error message? So yeah, what happens if this goes horribly wrong and we want to return a custom error message? So there's a fault message in there. There's a return a fault message in there, and you can also have a fault flow within Apogee. So you can either put a conditional error message in there, return your own error code, your own body and everything for that, or you can have an entire flow, which might do some logging and then return a custom error message in addition to that. So next question is, can Apogee host a web service with SOAP with no target? Yes, absolutely. I've shown HTTP, I've shown JSON and REST in here. But yeah, a lot of folks do SOAP in here. So you can have SOAP backends, you can have SOAP no targets, host your own web service in here, no problem. So yeah, as long as we can speak over HTTP, or we can do it through like a Java call out, easy to do. How would I unit test these examples? Yeah, great question. I would probably be unit testing from so 2 ways to test this. There's a trace utility built into Apogee. I didn't show it in the demo, but you can go through and you can see the whole execution. You can see the state of the system at each individual step within there, and you can see what the responses are that come back. I use that when I'm debugging my proxies. To test whether it's usable for consumers, I would do some calls to it. So I would set up a testing harness, something like I use Postman. I use this PAW program we've been using in here, and I use that to call my APIs. But basically test it, make sure you get back the response that you were expecting. When will Edge have direct integration with source controls? The next question. So we don't have direct integration in there, meaning that you can't hook up directly, but you can get all the source code from Edge and download that to your computer and then check it into a source repository. How can we handle the message size when we mash up? The size is based on a single API or the complete response. So the response size is going to be based on what the finished response is. So in this case, when I mash that down to that composite response, that's the response size. So it's going to be depending on what you expect from your backends and then however you filter whatever they come back with. Question is, does the circuit breaker pattern come into play at all in Apogee? So how do we prevent people from calling this too quickly and overwhelming us? Yeah, we have two policies that you might use to implement a circuit breaker pattern. We have the spike arrest policy. You can drag and drop that in there and you can set a calling limit so that somebody doesn't call too quickly. The other one is the quota policy. The quota policy lets you set a fixed number of calls. So 1,000, 10,000, 50,000, whatever you want to set in there. And that could be per minute, per hour, per day, or something like that. So both of those in conjunction, one would actually measure the calling rate, and then the other would measure the number of calls. Those can be configured programmatically, and you can dynamically insert values in there. You can have different rate limits for different callers based on who they are. Can we put the places information in the cache to reduce the places service calls? Yeah, absolutely. The next thing I would do to this, you saw me do 2 iterations of it. My third one would be to add response caching in there. So Apogee has an excellent caching system in there. And what I had planned to do was, cache the geocoding, cache the places because that doesn't change too frequently, and maybe put a 30-minute timeout on the weather so that you'd have a cache on that because the weather's going to change frequently. But yeah, I would cache those independently, and that would make it considerably faster. So what's the process to move between environments? How do you promote from QA to test to dev and things like that? So there is, within the Apogee UI, you can drag, there's a deployment option there. You can simply click on which environment you want this deployed in. There's a revision control system in there. So you might have version 3 running in your QA environment and version 2 running in your production environment. And you can move between those by simply clicking on those green dots. There's also a command line interface for this. So there's a whole set of REST-based APIs that you can call for deploying things. So a lot of folks will automate that. They might automate the push into production, and that's done by calling an API. So how will we change the URLs for like dev and QA and prod and things like that? So there's 2 different sides of this. There's the side that you call an Apogee. We'll call that the consumer side. And then there's the target side, which is the backend systems. So you're going to have different URLs for your different environments. If you have QA, test, and prod, for example, you get 3 different URLs, one for each of those. And then the backend, let's say we have a different URL for the backend, whether we're deployed in test or prod. That can be done programmatically. So you can just give this a name, and you can call it my backend or whatever you want to. When you drop that into your QA environment, it's going to go look up the URL for that. Or if you have it in the production environment, go look up the URL for that. So yeah, the URLs can be dynamically grabbed depending on what environment you're in. And you can do that with different rules. The question here is, can we control the quota policy per client application? Yes, absolutely. So the next step in this process is the publishing process. And what you would do is you put this into what we call an API product. And an API product contains one or more of these API proxies like I've built here. Along with that, you can specify some metadata, and some of that might be quotas. So you can have different products or different packages, if you will, that people can consume. Each of those can have a different quota. Imagine you've got a silver, gold, and platinum package. Each gives a different quota. You then generate keys that give you access to one of those API products that thereby gives you access to a particular API proxy. So different folks can have different rate limits, different quotas. You can put different routing rules in there based on who they are. And that's driven off an API key or an OAuth token or whatever we want to use to establish who they are and which group they belong to. So for this mashup pattern, can we support different transport protocol and then unify into a single JSON response? And if yes, how do you do that? So you can do whatever you want to do within those programming languages. So for example, let's say you've got something that doesn't speak HTTP at all. You could do that through a Java callout, JavaScript, or Python. get that data back in there, and then create that response inside the programming language and return it. So another guy's in here helping me with the URL question, thinks they're referring to the vhost option. So yeah, what that means is, yes, you can customize the URL on the caller side, also on the consumer side. So we can have multiple different URLs listening on the consumption side, and then we can also have different ones on the target, and they're separated in here. So you can specify multiple what we call virtual hosts, and within there they can have different names, different security certificates, and things like that. So where do we set the time limit that the caller will wait before a timeout? So by default, that's going to be 1 minute, and that's configured within Apogee. That is configurable. You can change that and set a timeout. Can Apogee interact with a service registry to get the microservices API endpoint URL dynamically? Yes, it could. Yeah, so we can specify what the endpoint's going to be dynamically. It's stored in a variable, and that variable can be changed however you want to do that. So you would need something to go look that up, and then once you get the answer back, you can go and replace that, and it'll happen before it calls the backend. So a few different options for that. Some folks will store that in a key value map if it's not going to change frequently. You look it up in the key value map. There's APIs to programmatically change that key value map, or have some code in there that goes and looks it up per call. Either way would work. So our next webcast is going to be on conversational UIs. So in that one, we're going to take a look at how do you make a talking UI. So let's imagine you wanted to talk to a Google Home and ask it some questions and then have it call your APIs. How would you do that? So that's what we're going to do next time. If this was interesting for you, for a one-on-one session, go ahead and email Mike Lofquist at google.com, and he can schedule a follow-up. So if you want to have us talk to your folks and maybe go into a little more depth on how this works or do a custom demo for you, we're happy to do that. And for an in-depth tutorial, if you want to get hands-on with this, join a virtual API jam. We're going to send all the links in the resources section, and we'll see you on the next webcast. Thanks.